So hi guys, as you have seen from probably my Zoom ID, my name is Matt Strong, and today I will be talking about undergraduate research. So I'll be talking about how you can get it, how you can really get in contact with the professors, and how you can just feast and feast at the research. And if you have any questions after each slide, just like let me know, interrupt. I have no problem with it. So let me start with a self-introduction first. So I'm currently a student in computer science. I'm a senior at the University of Colorado Boulder. So I've been doing research since freshman year. And so there are three kind of pillars to my research. So the first one is the main one. So it's a flexible robotic skin. So here we have like this robotic skin that's like super flexible and has a bunch of sensors on it that you can kind of wrap around a robot. And you can do some like cool calibration algorithms to figure out where these sensor units are on relation to the robot's body. And this can allow for like super smart stuff and super safe control. So the next pillar of my research is something called HRL, and that stands for hierarchical reinforcement learning. And I think to explain this, it's best motivated by an example, and I'll go in that a little bit later. And the last pillar of my research is called high performance computing energy simulation. Basically, the goal of this is to model buildings, so all kinds of buildings, hospitals, churches, homes, and see how can we use waste the least amount of energy. And to do that, we basically simulate these building energy usages over a year. And then we do some machine learning to see like what can we optimize and waste the least amount of energy. So through this research, I've been very fortunate to have been nominated for the Computing Research Association Outstanding Researcher Award in North America for all the CS undergrad researchers. So that was really nice. And excuse me, a fun fact is that I am half brown, but I like to round up. So I'm basically full brown in my eyes. Cool. So this is my research group. This is the robotics group, and if you can see my mouse, right? Can you guys see my mouse?
Yes.
Okay, cool. So this is me, of course, and this is my whole research group. And the main thing I want to point out here is that it's obviously a good group, but the main thing is the mountains. As you can see, the mountains are beautiful. And in fact, they even look better if you were there in person. So I want to say that everyone here should go to Colorado at least once in their lifetime and experience easily the best state in this nation, without a doubt. It's the healthiest state as well. So yeah. So a little bit before I talked about this HRL thing, hierarchical reinforcement learning, and this is the example I will use to motivate it. So here we have this task. This little creature, we call it an ant, wants to go through this maze, and the goal is to go around this maze, and it's considered a success if it gets to this red sphere right here. And so to solve this problem, we apply HRL. And the reason it's called hierarchical reinforcement learning is that you basically have two controllers, and it's similar to how humans think. So the higher level like decision-making process, it says, oh, the goal is over here. Let's assign sub-goals along the way to get to this target. So an example of a sub-goal might be this ant moving a little bit forward, then moving a little bit more forward. And so it just keeps going, and then eventually gets to this corner. And then it needs to turn a little bit. Then it needs to move a little bit forward, and etc. And eventually all these goals will lead to hopefully eventually getting in this red sphere. That's considered a success. So there's a second part to this. So you basically have these sub goals, and the lower level controller, as they call it, takes these sub goals into account and says, okay, based on this sub goal, here's how much we need to move each joint to meet this minor goal. And so that's basically like kind of joint angles, like how much do you need to move this limb right here so you can get to this goal right here. So it kind of breaks up this whole task of getting to the end of this maze into two layers. And I would say that this process is inspired by how humans think. So let's say I want to pick up a water bottle. So there's like kind of a hierarchical way my brain thinks. The first layer says, where does my hand need to be in space to get closer and closer to this water bottle? And then the lower level controller says, okay, based on like each goal of my hand needing to move here and here and here, how much do I need to move like my elbow, or how much do I need to move my shoulder to get there? And so kind of the angle I need to move my shoulder, that's more of a low level action. So the results of HRL have been super good. It blows kind of the standard reinforcement learning algorithms out of the water, and it's the future. So if you guys read HRL, really read it. That's my advice. So the next part of my research that I'll elaborate a little bit more is called the robotic skin. And so the robotic skin, what you do is you place just a bunch of like skin patches onto this robot arm. And so my team and I, we developed a calibration algorithm so you can figure out where these skin units are on like the robot's body. And to kind of understand why this is needed, think about humans, for example. My arm has sensing units long right here. And so I need to know that these sensing units are on my arm. Because if my brain thinks that these sensor units are on my leg, if I feel pain on my arm here, I'll think I'm feeling pain in my leg. And so I won't know like where my sensors are. And that just is completely ridiculous. So that's the main thing, is you need to know where these sensor units are. And then once you have these like the skin on the robot, it can basically sense how close things are. It can even do some little bit of perception, and it can safely avoid like obstacles and humans. And then kind of my last research, and actually this is my least favorite because I don't know, it's just my least favorite for some reason, is the building energy simulation. So this is a software called Open Studio. And here you can basically have this building, and then you can add like a bunch of features to this building that will affect how much energy it uses over a year. And so this is kind of cool because you kind of get to see this graphical representation of what you're working with. Let me get some water real quick. I'll be very thirsty through the presentation, so I'll be drinking a lot of water. So now let's get into like the main stuff, undergraduate research. And then important point is, if you remember the old picture that I showed previously of my lab, this fellow right here is my supervisor. And then this arm here was the previous arm. It's called the Franca Panda. So yeah. So a lot of you might be wondering why research. So I would say there's a few reasons. The first reason I would say is to advance the field you're working in. And in research, there might be some problems that have been solved, but they've been solved poorly. Or there have been problems that just literally have not been solved yet. And when you solve this problem, or the solution to the problem is even better, you're basically advancing the field that you're currently working in. So in robotics, for example, when I was talking about finding where these skin units are in a robot, there was a solution that existed, but the solution was super bad. And it basically was like 1 meter off. So it's like, it said like, if you put a robot skin unit like on its end, the algorithm would think it was at the base of the robot, which is just completely wrong. So another reason is to work on fun and interesting problems. And I would say that this is just, once you guys get to college, it's just way better than just class assignments. Because in class assignments, there's guaranteed usually to be a solution, and there's kind of like one way that you're supposed to tackle it based on the stuff you've learned. Whereas research, you just have a problem, and there's not like an easy path to say, oh, you should use k-means clustering, or use this algorithm or this technique to get that solution. Because no one's come up with a solution before. There's a lot of, and I mean a lot, of free reign where you can go to find like any solution that you want, as long as it works. And it's really fun to work outside of, kind of working in this environment is a lot more free, and it doesn't feel as stressful, which is weird because you have all these paper deadlines, but you don't have like all these weekly deadlines for these assignments. And it just feels like you can really commit yourself to research. Another reason, and one of the biggest reasons I did it, is to challenge myself. So at least at my university, some of the classes, they don't really try to hit hard some of the main concepts in CS. So when I did research, I found that I was forced to learn some of the main concepts of CS, but also I ended up learning random stuff like electrical engineering, mechanical engineering. I ended up learning a little bit of control theory, and it was all to kind of find the solution to a problem. And lastly is improving job prospects. So I believe that having good research experience on your resume helps you with industry, like applying for full-time jobs, because it shows that you really put in time to get some results on a problem, and also internships. And potentially, excuse me, this can really help with academia, because if you have a really good research track record, you can ultimately get admitted to a really good PhD program in computer science. And then you can just beast and feast at that PhD computer science program. And then from there, you can like be a professor. You can like be a research scientist at a company like Google or DeepMind or OpenAI, or you can just be an engineer. But I think the research experience really helps out. And then the picture here that I want to call out is a product of research, and it's called YOLO. And so you might have seen this kind of diagram a few times, maybe 100 times. And so YOLO stands for you only look once. And it is a object detection algorithm, as you can see from here. It detects dog. It detects like a bicycle here. And then there's also like a truck here. And so this is being really used a lot more in industrial applications. But the origin of this algorithm was from some lab in University of Washington, where some guy had this fast way to detect objects, and he coded up some model, and it worked, and the results were really good. So in that sense, I would say research and industry really come hand in hand. So originally, when I was a freshman, I thought that research and industry, it was just like they hate each other. But when I did like an internship this past summer, I learned that researchers really have to work with folks in industry. Get some water real quick. So here are the like first steps to kind of approaching how to get research. So the first one is to attend research talks that interest you. So you might see your school post some random talk by this random professor, and sometimes the topic might not seem like the most cool thing. However, if there's even a little bit of an ounce of coolness, I would recommend going. And one of my anecdotes for this is that I used to be a member of a club called Society of Asian Scientists and Engineers. And I think some professor was going to give a talk there on like some random day. And it was about building simulation. And because I didn't hear like anything related to CS, when I heard what the talk was going to be, I at first dismissed it. I thought this is going to be a waste of my time. It's only for those noob civil engineers. Why would I go? But another friend convinced me to go because he was a civil engineer. He's like, you're being a hater. So I ended up going. And after going, it turned out there was a lot of application of computer science for it. And so I later reached out to the professor about research. And that from that one talk, that ended up becoming my first research experience in freshman year. Now, the second point is to listen to your professors when they talk about research. So while this does kind of imply to not ditch all of your classes, I think it is still important that when they say, oh, here's kind of the research I do, to really listen to what their research is. Because when a professor's at a university, their main job is to do research, and their main job is not to teach. Some of them like teaching. Some of them not big fans of teaching, but they kind of have to, so it is what it is. But all of them have a PhD generally and are there to do research. Now, the third point is to read news from your university about cool research. So sometimes, like, if you're going to a school like CMU, maybe they have like an engineering group that posts like whenever cool research comes out of CMU labs that says, oh, some cool lab like at the Robotics Institute is doing this really cool research on drones and mapping. So I would encourage all of you to, when you see this kind of news, like read what the research is about. And also, just as important, I would say, read the PhD students who are working on it and the professor who's advising them. Because later you can contact them expressing interest in research. Now, the fourth point is to ask your friends, peers, even like your academic advisor. So your friends might know some researchers. They might be in research. And so that's really good to ask. Your peers also might be in a similar boat, so I would recommend asking in that case. And for your academic advisors, I would say generally they know the department, they know which professor is working on which like department, and so that can kind of guide you to which professor that you might be interested doing research with. And lastly, I encourage you guys to search online, just kind of randomly search online and look for labs that interest you. So I'll give you an example of if you attend CU Boulder, how you can do so. So if you go on Google and you type in CU Boulder Computer Science Research, you'll get a site, let me check the time, you'll get a site that shows up and it looks like this. And so there's a cool video. Of course, the thumbnail involves a robot because robots are the best, in my opinion. And if you were to scroll down on this website, you'd be able to see the different departments of computer science and each of those departments, which each researcher is associated with it. So you can eventually contact them. So just doing a simple Google search of like, let's say you go to, you're going to Stanford, just Stanford Computer Science Research. And I would say more often than not, you'll get like a Stanford showing their research departments. And then if you click on each department, you can see which professor is working in which department. Let me get some water real quick. Okay, so now for research networking tips. So you have found something that you're interested in, you see some research that you want to do. How do you go about and continue to execute that plan? Firstly, you should ask one of your professors whose research interests you. And one of the good techniques I've learned for doing this is to stick around after talks and lectures to ask questions. So I would say generally after a professor gives a huge talk to 300 like students in an auditorium, it's not like half of them or even like a fourth, maybe even eighth are just going to go to the professor and be asking about all this craziness. It's pretty common that most of the people are going to leave this auditorium and there won't be many people, which makes it much easier to go up and approach the professor and ask questions. The second thing, or sorry, I guess kind of the third thing you should do is to just cold email a professor that you've never met. And that's kind of actually what I did. So I had a friend that said, oh, there's this robotics guy and he's looking for students. And I didn't know this robotics guy at all. So when I emailed him, it was just like some random student just emailing him saying, yo, I'm interested in research. Here's what I've done. Can you help me out? And the fourth point is having a friend or a peer who is currently in the lab to kind of introduce you. And so that's one of my tactics in my lab that I've actually been trying. So I'm in currently like this robotics lab. And if I have a friend that seems interested in the lab and they've kind of demonstrated that they'll put in the work to really get results in the lab, I find that it's quite easy to just talk to the professor and say, yo, I can vouch for like LeBron James. This guy is legit. He is going to be a great researcher in robotics, and let's get him in ASAP. And I would argue that this, I guess I would call this a referral in research, is a little bit more powerful than a referral at like a big tech company. Because like at a big tech company like Facebook or Microsoft, for example, sometimes you might have a referral and you'll be like, yeah, I got a referral. But then like tons of other people are getting referrals. So at that point, it might be hard to get to like the first round. And even if the referral helps you get to the first round, there's still like a bunch of barriers and like stages you have to go through in order to get the job. So kind of the research referrals are really powerful. And especially because research labs are not big companies. They're a little bit more like a family, I will say. And it's not like they have thousands of people in one lab. Because like I would say in research, like a research lab like mine, for example, you'll know the professor quite well. And you won't be like, he won't be like a teacher, he'll be like an advisor and at times a peer. So for contacting a professor, my biggest tip is to be brave. And I would say professors are actually very cool people. And they become even more cool when you talk about research. Because like I said in some previous slides ago, they work at universities primarily to conduct research and not to teach. So these professors have years of research experience. They have a PhD where they really tried to find groundbreaking ideas in their topic of research. And I think a decent amount of professors, they do like to teach, but it's not like they are saying, yeah, I want to be a professor just to teach. But they're also saying, I want to be a professor to be like the director of a lab and really advise and empower PhD students to push themselves to the limit and do the best research they can do. So when you talk to professors about research, I think their aura just completely changes. So at first, when they're kind of giving lectures, they seem not as like, yeah, this is so cool, this is the groundbreaking stuff. But when you talk to them about research, research is that groundbreaking stuff. So when you talk to them about this groundbreaking stuff, you'll notice kind of their eyes light up and they'll just be like, oh yeah, bro, like I'm doing this epic stuff with robotic mapping, stuff like that. And another point is that you have nothing to lose. So even if you don't hear back from a professor, reach out to other professors. And then this diagram here kind of shows that in professors' eyes that the research, so these are greater than symbols. The research is quite more important than teaching. It's like you don't want a professor to teach stuff like 2 times 2, 3 times 3. They might like it, maybe a little bit, but they're like, it's okay. So when they get to do research, this is like 100% new stuff. It really relates to their field. And so I think it's much more just invigorating for them. And then I guess this interesting tidbit here is that this robot is that same Franka Panda that you've seen 2 times already. If you have tons of money, I recommend buying it. It's like $30K, but it's super good. And then this fella right here is one of my current PhD mentors. Let me get some water again. All right. So you're getting really far in this process. Now, how can you like lock down that job and just get it done? So when you talk to professors, make sure to emphasize their goals. I wouldn't say like you should say something like, yeah, research is cool. Yeah, this is cool stuff. Rather, if you bring your goals into it, if you say, if like you're talking to a biology plus computer science lab, for example, you could say, yeah, I really want to pursue kind of a career and do a PhD in combining biological networks and computer science. Or you want to say, oh, I'm also minoring in biology. And I think by joining this lab, I'll be able to get both my major and minor combined and really understand how they combine. Additionally, demonstrate passion or interest is quite important. So when you talk to a professor about their research, it's very likely that they'll demonstrate passion because it's the research that they kind of signed up to do and lead. So if you can reciprocate that passion and really show that their research really interests you, my eyes, they are much more likely to bring you on the lab. Also, explain how previous experience qualifies you for the role. So even if it's not super related. So as some of you guys are high school interns, you might not have like research experience in like a lab, but you might have experience in just computer science. And if you can bring in how that really qualifies you, that this like project, this web app I did really demonstrated that I can get a end-to-end thing working within this time frame. I think it's very powerful and much better than saying, yeah, I'm a hard worker, I'm motivated. That's like anyone can say that really, but not everyone can say they interned at Slingshot. That's a legit thing. So that I think would really help in this case. Lastly, attach your resume and GitHub on the first email. Because if you don't attach your resume on the first email, let's say you say, yo, I'm Matt, here's my goals, I'm interested in your research, thanks. So the professor will respond, but sometimes they might see, let's see more of your experience, can you send an email about your resume? And so that makes the email chain just a little bit longer. And if you can really demonstrate your whole self on the first email, I think that's the best way to do it. So as this point says, it gives an even clearer picture of what you can bring to the table. Check the time. I'm on time. Okay, cool. So here's what I wrote to my professor. So I'll kind of let you guys look over it, and I'll call out the kind of the main things. So for me, the main experience that I said really helped with me being qualified for this lab was that my friends at the time were founding this startup called Udana, and it was like drone delivery. And so through this, I had ended up learning a lot about robotics and even like computer science. I actually learned web development from doing this because I had to like set up our web servers, and I had to set up our website and all that. And so I said I have experience with robotic software as machine learning frameworks. And then I also additionally mentioned that the work I am doing has private repos, but I can show you what we're doing. And so at this very first email, I made it clear as well that I think it would be interesting to see how we can integrate aerial robots. Like I specifically stated what I wanted to do. I think I attached my transcript, which I don't know. I don't think that's necessary, to be honest. I don't know why I did it at the time. And then I attached my GitHub so he could see like the robotics work I had done before and just like CS work in general. So let's say like you're a high school intern from Slingshot and you're in college at like a university and you don't have a lot of robotics experience, but you do have the computer science experience. I think that's very powerful as a freshman. If you bring on the first email, I'm interested in robotics. I haven't worked a lot in robotics, but I have a lot of good computer science experience. I think that will really help. And I'll bring in another kind of personal anecdote. It's, I guess, a friend anecdote. And it's that he wanted to do research in, I think, biological networks and computer science. But he had zero experience with those two specific things being combined. However, he did have a lot of like GitHub stuff. He was just very interested in computer science. He had done stuff like neural style transfer, which is super cool. If you guys, I think it was a tech talk I showed like a picture. It's just super cool in my opinion. And so when he reached out to this professor, the professor was like, it's probably likely that newer undergrads aren't going to have right off the bat just experience with biological networks, and computer science. But when he saw this guy's GitHub, he noticed that he was clearly very passionate about computer science. And he had done work before, not related, but this work demonstrated that he could get stuff done and he could get stuff to work. And so I remember when I was talking to this professor, he straight up said, when I saw this guy's GitHub, he was in. So I think that was a really cool point. Oh, and also for this email, I'll mention that this was a successful email. After this, I was in. So I didn't have to send like 100 emails after. All right. So you got the job. Let's say you were beasting and feasting. You were super successful. Now what? Get some water again. Oh, and this picture right here, this is another lab in CU Boulder. It's not really a competitor lab because they do like ground robotics and a lot of electrical engineering. So there's another CU Boulder lab. And I will say the robotics labs here are actually quite good. I think they're top 10 in the nation. But CMU is number 1. All right. So performing well at research. So the good news is you're in. The somewhat bad news is frequently you will not be able to do the fun stuff first. So generally the fun stuff is done by the PhD students because they're the ones that need to get the research papers published. And so they're doing all the problem solving and all the like coming up with the solutions to these problems. And as a professor, if they see an undergrad who has a lot of potential, but is not like have all this crazy research experience, naturally it makes sense to not give them just the crazy robotics like tasks and algorithms. Instead, they'll give you kind of more easier tasks, but it does get better if you stick it out. So I think my second lab experience, I really learned about the importance of sticking it out. So I was really happy to get in the lab this robotics lab. I was like, sweet, I'm gonna do robotics stuff right off the bat. However, the bad news is that the professor's like, we need to get set up some deployment for this website. And I was like, inside I was saying, are you kidding me? I'm doing web development in a robotics lab. And it just seemed completely stupid. But I was like, maybe this will lead to good stuff later on. So I set up Netlify for the website. So you can see like deploy previews. So you can see like how the website will look whenever someone makes a new PR, like with their bio or something. So I started out with web development at my first robotics lab. That was quite interesting. And so I felt good about setting that up. And eventually I was like, yeah, I'm going to do more fun stuff now. I proved myself already, but not so fast for me. Instead, I set up continuous integration, continuous deployment for some of the new robotics repositories. And it involved like a little bit of robotics, like knowing what commands to do that would build this workspace, this thing called robotic operating system workspace. But it was not like robotics, like getting right into the core of it with the awesome algorithms. So I set it up, and then I was like, oh, is it gonna get even more boring from here? And I guess it got a little bit more boring because I had to start debugging just random code. And the thing with this random code I remember working with was that it was already like the algorithms already existed. It was just like these like silly errors, like runtime errors that would just like randomly show up for no reason and weren't as robotics related. However, as I got to do more and more debugging for these people's code, I ended up having to learn their algorithms along the way. And so as I learned the algorithms along the way, I was like able to see that, oh, there's a higher opportunity to grow from these algorithms. Like there's a way we can improve this algorithm. And so this was really helpful because I just kept going at it. Eventually this team called the robotics skin. So that robotics skin I was talking about, there's like a sub team in my research lab. And so they said, you want to join? And so, well, they made me start at first doing stupid stuff like testing and CI/CD. As I debugged some of the algorithms, I was able to kind of figure out how we can improve these algorithms. And so this really kept going on. And the tangible result of this is I'm going to be a published author in one of their papers. Okay. So I would compare to starting out in research is like these two pictures. The first picture is like you have the job at this company, but you're just sweeping the floor. And someone's got to sweep the floor. Like someone's got to do it. So it's an important job that has to be done. It's not that important. It's not that fun. And it's not as like relevant to your specific goals, but it is a way to start from. And through, I think, hard work, determination, and passion, you can eventually get to this point where you're working in a functioning team. Let's say this is like the research team lead. You're getting to contribute valuable ideas and ways you can improve like algorithms and their research in general. So I think, especially as like a freshman, you might start out like kind of doing the sweeping the floor task. But as a freshman, you have a lot of time. You have 4 years to just keep growing and get to this point. Like maybe even freshman year, you can get to it and contribute meaningful research. So I would say the earlier the better, and always Mamba mentality. So some continued points for this. So the takeaway is, it won't be so fun at first, but if you work hard, put in the time, and ask for constructive feedback. And this third point, I cannot emphasize more, because some people in research they're just brilliant. And they won't necessarily just give you feedback based on your work, but it's more likely that you have to reach out to them and say, yo, I wrote this research about drones and reinforcement learning. Can you like help me advise it? And I've learned that research people can be a little bit savage when they're kind of giving you the constructive feedback. Like I've had my advisor openly curse at me, say, this is effing garbage. Like this paper makes me want to kill myself. But if you see past it, that they're really trying to help you and push you, I think that's an important part of it. And do understand that this is hard, but again, the working hard time, getting the feedback from mentors and professors is crucial. And before you know it, you will be able to see the results of your dedication. So now let me get into the next section of this talk. And it's going from a research assistant, so like assisting someone in research, to get some water real quick, to becoming a researcher. And so this is where you're leading your own research. And for me, this is akin to just being thrown out in the middle of the night in just a dark forest, the wilderness. And you're just like, where am I? Like, what do I do from here? And the main thing is you just got to keep going. So in general, research is very, very, very incremental. By this, I mean, don't go for some like next crazy idea, for like new novel, crazy idea, and just knock it out of the park, because it's very hard to do it. Instead, I recommend to work up to it slowly. So let's say you have this object detection algorithm. By being incremental in your research, it would be improving like certain metrics of this object detection algorithm. Or if you have like an accuration, like a calibration algorithm that you can see to see how accurate it determines how like these skin units are on a robot, like how accurate they are from like the real robot. It can be just a matter of changing the old method a little bit up, and then having like decently better results, and not like better results by chance, but better results. So the goal of this, and as a researcher, is to expand the limits of human knowledge, which sounds super cool, but it's not like you're expanding every like alley of human knowledge. You're not like expanding the knowledge of how mice work, or like, I'm trying to think of another example, or like how to make phones better, or how to cure like this every disease in the world. Instead, you're trying to expand a very, 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 very specific area of knowledge. So this picture right here, I think, is a good motivating example. So I'll explain what these circles mean. So this huge circle is all of human knowledge ever. So this blue circle here is the stuff you learn in middle school. And it's a perfect circle because you don't really focus on one like discipline like super hard. Like you don't really, really drill down computer science. You have just like a bunch of core classes you just have to take. You have like the standard math, the science, social studies, English, reading, writing, maybe music, maybe like wood shop, just kind of general skills as a student. So that's why it's a round circle. Now this green circle here, you learn more, is high school. So it's high school. And here, you still don't really specialize in stuff, because you still have to take like the core classes. You still have to take English, math, science, social studies, etc. And you can't really focus on one like discipline, even in high school. You can probably take classes to focus more on something like computer science. Like you could take AP computer science, for example, but you don't really get to drill down into one topic. So that's why the high school circle is also pretty round. So then you get into undergrad research. So if you look here, if you can kind of see this little stub right here, this is called your major. So this area is still round here because it's quite likely you have to take like core classes. Like there'll be a writing requirement at your school. At least at my school, I have to take writing. I have to take, in my opinion, a lot of classes I don't want to take. Like I had to take geology. I had to take like classes on atmosphere, just kind of like random classes. To be honest, those classes were a waste of time, but the school is the school, and I don't have a decision over that. However, because I'm majoring in computer science, I take more computer science classes. And so that's where the stub comes in, that my knowledge in computer science kind of stubs out from just my general knowledge and just everything. So then you get to, let's say you do masters. You can actually do undergrad to PhD, but that's reasonably rare. So let's say you get to masters. in computer science. So if you can see, this is kind of hard to see. It's like a little bit bigger spike. So in master's, luckily you don't have to take as many core classes, just like meet writing requirements and all that nonsense. Instead, you focus even more on computer science. So that's why it grows out even more. Some water real quick. And finally, you get to PhD in computer science. So in PhD, the classes you take, they are related. Like you take very few classes. The PhD students I know only have to take like a few classes. And the reason they take a few classes is because the PhD is a research-based degree. So you're mainly focused on research, not just taking classes and doing stuff. You're just focused on really getting research, really getting those publications. So in this matter, it forces you to learn the state of the art in this one specific field. Like let's say it's blockchain, like Aqua was saying, get the state of the art in blockchain. And so where does the research come into play? And so if you look at this diagram right here, this little bump is you penetrating the whole circle of human knowledge. And it's making the human knowledge just a little bit, increasing it just a little bit. It's in that very, very, very specific area. But you can see you're bringing out a novel idea in this one field. And this here is the PhD. But it's also, as you're a researcher and not like just assisting someone, this is what I would say is doing research. And this kind of diagram here kind of explains just research best, in my opinion. Because it really shows that you're kind of just learning all this general stuff in the beginning. And then when you get to PhD, you just drill to the core and then even past the core of your research. So, like I said, it's transitioning from assisting a PhD mentor to being your own researcher. And you are the one coming up with these novel ideas. So you're not just like implementing with what your PhD or maybe master's mentor tells you to implement. It's you're the one who has to devise these new ideas. And so the biggest tip for this by far is read, read, read. Because you need to understand like where your work, your novel work will situate itself in all of the current research related to your topic. So if you don't do any research, then you might think like your algorithm is completely novel. But if you do read research, you can kind of see maybe that your algorithm isn't novel, but instead you could really maybe improve from this one algorithm and improve like some metrics of it. So I think reading, like I can't say enough how important reading is. I'm still learning it as I'm doing research right now, that if you don't read, then it's just much harder to really understand how you can make an impact in the field. And one thing I also want to mention is that as like a researcher, I used to think that you just had to be just genius and just like know all the craziest research off the top of your head. But I think being just a brilliant researcher mainly comes from just reading and committing to read. And so if you really commit to it and like ask people to help understand research papers, that will in turn make you a much better researcher. Another side thing is that when you implement other methods from papers, you might be able to see like as you're implementing them that, oh, this method has some problems in this regard. And then we can improve off these methods. So one of my PhD mentors, actually, he was reading papers, but he was still kind of lost. So his advisor told him, oh, Caleb, you should implement their method and see what shakes loose. So he implemented this other method, and he noticed that as he was implementing this method, there were a fair amount of problems with it. And the research paper didn't address those problems, because when you're writing a research paper, you don't want to say, my research is super good, but actually there's all these problems. Sometimes people will kind of sweep that under the rug, and then people will find it a little bit later on. True story. But as this guy was implementing the method, he found many issues with their method. So he was able to kind of reformulate the way they attacked this problem, and it actually is going to lead to a published paper by him pretty soon. So here's like a good example of like incremental research. I think like this is one of the best examples that unfrighten me, I guess, because I used to be like super scared. I was like, these names and titles of these papers are just monstrous. And then when someone like really explained to me what was going on, I was like, oh, it's not as bad as I thought. So here, this is a archive. You can actually find a lot of research papers on archive.org. So just keep that in mind as you read research papers. So this paper titled Asynchronous Methods for Deep Reinforcement Learning. It's a long title. It was a big deal. And so this paper was really successful at like solving some Atari games. It was able to have things navigating 3D mazes using like the visual input. It's like for robots going through a maze. And the results blew everything out of the water. And it was a huge paper. I think it's one of the most cited papers in RL. It had actually nearly 4,000 citations. So 4,000 citations in research is, I'm trying to think of like, let's say maybe it's like having 100K likes on Instagram. That's how I might view it. Like 4K that is huge deal. Like having one is really good. It means people are like, yo, Matt's work is legit. I'm going to cite it and say so-and-so. So this was a big deal. But the next slide. So this paper it also seems like a big deal because it had 1,000 citations. So that might be like 25K likes on Instagram, which is like super good. Like let's say you had a picture and you get 25K likes. Like that's quite crazy. So the paper is entitled Soft Actor Critic, Off Policy, Maximum Entropy, Deep Reinforcement Learning with a Stochastic Actor. Whew, I take a breath. That was so long. So this is it's quite a nasty title, right? It's so long. And if you compare these titles, it just seems like there's completely different concepts. Now the people in this paper, so this Tuomas guy, he just had some brilliant idea just come out of thin air. He's like, oh, I'm genius. I'm going to have this new method and it's going to be better than all the other methods. However, that was not the case. So at first, when you see these like on the site, you're like, wow, it just seems intimidating, right? However, upon reading the papers, it tells a different story. So the first paper was quite good. Well, it was extremely good. It had 4,000 citations. So the second paper, which sounds so different, but the only difference was that it added an extra term to the objective. So in reinforcement learning, the objective function is something you want to maximize because the goal in reinforcement learning is to maximize this thing called reward. So like in the that old example of that ant thing going to the maze, it gets a higher reward if it's closer to the goal, which kind of makes sense. That you should get penalized more if you're farther away, and you should get rewarded more if you're closer to the goal. And so all this did, so like you have this objective function, let's say f of x. All the second paper did was just add an extra term. So that's just saying like this objective function called f of x becomes f of x plus, I think it's a pretty basic term. It's called this entropy term. And it's not like a nasty equation. It's written in like, it's actually very short when I think about it. So that was quite crazy for me to hear that this paper that had 1,000 citations and just sounded like a random idea that came out of nowhere. And it just was like the product of some brilliance that can't be taught. It actually wasn't. So it's literally, they just added the extra term, just like plus like this function. And that was it. They just added the function. And it's not even that like impressive of a function to see. Like when I saw it, I was like, why didn't people think of this before? But the main things I want to point out is that they did mathematically show that it was better. So you have to kind of justify that in research that your method is like, it's better. And you can't just say, yeah, I just threw this in. Yeah, it looks good. So it's better. And they also did conduct a ton of experiments, which as you're doing like research assistant and researcher, it's very important to just do a ton of experiments. Because like the more, the merrier. If you can show you have 1,000 or let's say 100 experiments and the results are noticeably better than the old method, then that's very important. And lastly, this idea, although I don't understand why it was novel before, it was novel. So someone had not written a paper about this before. But let me also call out that this extra term exists in machine learning. It just wasn't combined with reinforcement learning yet. So like if someone just said, yeah, let's just do plus this term, boom, that's a paper. And so this was just like kind of the like, oh my goodness moment for me in research. And it just shows how incremental it was, that the titles, they do seem intimidating, but upon reading it, you see that it's literally just one thing they just threw in. And then that became like this became a huge algorithm called soft actor critic. It's used a lot in baselines, and it's used a lot these days. So that's one of the best examples I'd like to show. And also the picture on the right, I want to show that even one step is an improvement. So even if you're going up one step, you're going up. You're slowly advancing the limits of human knowledge, slowly going up and up and up. And if you're curious where this picture is from, this is from a place called the Manitou Incline in Colorado Springs. And so there's actually a false summit here. It's the height of the Empire State Building and stairs. It's like the Stairmaster. And I kind of threw this paper to show, I threw this picture in to show that one step is an improvement, but also to make sure to reinforce the idea to you guys that Colorado has some of the most beautiful and just epic places to go. So if there's nothing you take away from the research, there needs to be, at least one thing is Colorado is the best state. It's the most beautiful state, and you should go there. Check it out. All right. So finally, my overall takeaways to all of you guys. Reach out to professors. Like really reach out to them. Be brave. Like I said, you have nothing to lose. And I would say professors do not ghost you as much as those folks in industry. Like ghosting in industry, it's rampant, I will say. It's quite rampant. So like, for example, the company that I'm working at next year, I like emailed a recruiter, but I've been ghosted for, I think 3 months now. But in research, I would say like very often in time, the professors will reach out back to you. The second point, don't expect to drive your own research at first, but so there's two things. I'll just compress it into the Mamba mentality. Simply with the Mamba mentality, you can easily get there to this position where you can do just the fun stuff and really just solve the fun and exciting problems. And lastly, seek out constructive criticism. So seek it out from the advisors, the PhD mentors, folks who have done really good research. And at times they can't sugarcoat it, because I believe that sugarcoating in research never works. You need to tell them exactly what's wrong. Like sometimes the professor will be savage, but they're looking out for you. They want you to push yourself to the limits and really improve your research as a whole. And so I have a quote here by Confucius, and I think it really kind of has encompassed my research experience for me, and I want you guys to keep it in mind, is this: the man who asks a question is a fool for a minute. The man who does not ask is a fool for life. And that's probably one of the best like things that I've learned to go by in research is like be brave. Some of the most brilliant people I know, when they were like starting out, they were asking just so many questions, and just the fact that they asked questions, they just learned more and more and more and more. So in my eyes, it's not that the researchers there, like some of the brilliant researchers are just like they just are gifted out of nowhere. It's that they had to put the work to grind, but as they were putting the work, ask questions for feedback and continue to improve. And with that, that is my presentation. And now it's Q&A time. So if you guys have any questions, let me know.